Hello and welcome to the video. In this one, we are going to set up oats locally, get familiar with the OpenAPI document we are going to use for the rest of the series, and also have a look at the generated code, so in the next video we can jump straight into development. To follow along, which I would highly encourage, you will need an IDE with TypeScript support, preferably Visual Studio Code. You will need Node and npm to be installed, and you will also need to be familiar with the TypeScript language and with the structure of OpenAPI, at least at a basic level. So I'm in VS Code in an empty folder. In order to save time, I'm going over to the oats demo site to get started with our dependencies and our generator code. Link to it is in the description as usual. This page allows us to experiment with oats right in the browser, and also allows us to set up basic configuration on a UI and gives us the appropriate code that we can use in our local project. I have a dedicated video showcasing it. It's the previous video in the series. I recommend you have a look if you haven't seen it already. I'm going to the configuration page, then to the reader section. I'm setting the protocol to HTTPS, the language to JSON, and I'm selecting the bookstore sample as input. We are going to have a look at this in more detail in a bit. I'm going over to the generator section. I make sure we are using the preset configuration style, and I'm selecting the server preset, as our first goal will be to implement a backend. I'm setting the root path to source/generated. This means that all our generated files will be under this folder. Lastly, I'm going to the writer page, and I make sure we are writing our output to the file system. Now I'm just going to open package.json, which is populated with all the dependencies we need to get started. Then I'm creating package.json in my current empty project, and I'm going to copy paste the contents from the demo site. Now we can run npm install. While that's doing its thing, let's go back to the demo page and open generate.ts. This file has self-contained, configured and runnable code that will generate based on the configuration we set up here on the demo page. I'm going to create generate.ts locally and copy paste the contents. Before we move on, I just want to emphasize, what I did here doesn't mean that Oats is a monolithic tool or even a framework. The demo page simply exposes the minimum amount of dependencies and code we need to get started, and since we are in a brand new project, I'm using it as is. But you can also easily integrate it into your existing project as well, as it's a simple library that doesn't assume or expect anything about your project or its structure. It looks like npm install has finished, so let's try to run our generator locally. In package.json under scripts, the demo site created an entry which runs generate.ts using npm run oats. So let's do that. While that's working, let's go back to the demo site, and I'm going to do a quick walkthrough of our OpenAPI document. Let's go to configuration, then reader, and then I'm going to load this document into the inline editor. I based this OpenAPI document on the official pet store sample, but geared it towards showcasing the features of Oats. It represents a very simple API with a few endpoints that are capable of querying and creating books. We have two reusable schemas, book, which will be our main data model, and app error, which we will use to represent any errors that might happen. We have two paths, /books and /books with a book ID parameter. We can hit /books with get. This will return a possibly paginated list of books, or a list of app errors if something goes wrong. And we can hit it with post. This will need a JSON request body, which needs to match the book schema. In turn, this endpoint should persistently store that book and return the freshly created instance, or a list of app errors if something goes wrong. The path with book ID only accepts get, and this will return a single book that has the given ID, or just as the rest, app errors if something goes wrong. Now let's have a look at what has been generated from this. All the generated code should be under source/generated. With our current name and path configuration, each generated artifact is put into its own file and is grouped into folders by concern. Let's start with the most important one, the API type. My vision with the server-side part of this project was so that users of the generated code will only have to implement simple functions where they receive sanitized and strictly typed input data, exactly the data expected based on the OpenAPI document, no more and no less. And in turn, they can return the data the client expects based on the same OpenAPI document. Another core idea was so that the user of the generated code should never have to modify the generated code by hand, as subsequent code generation would either result in business logic being erased, or would need overly complicated logic for merging old code with new from the generator side. So this is the reason why I didn't do this by generating empty function stubs or something like that. We will have to create an implementation of this API type as the core of our server-side logic, and do a few additional steps to wire everything together, which will happen in the next video. The methods on the API type are named based on the operations in our OpenAPI document. If you are not familiar with this term, operations are the objects under a path and a request method, and they basically represent a fully described endpoint. You can see that each method has an input parameter called request and should return a promise of some response type. You can find the request types under the request folder. They basically combine all the input parameters for an operation that the consumer of an endpoint needs to provide. They are obviously strictly typed and tailored for the given operation. This includes query, path, and request header parameters, and request body with MIME type if needed. And the response types can be found under the response folder. Similarly to requests, they combine all the possible data an endpoint might return. MIME types and status codes together act as discriminators on these, so you can't mix, for example, a status code with a response body it doesn't belong with. In our case, let's say in getBookResponse, you can't return a book with a 400 status code, as this would conflict with the response type and with our OpenAPI document. Request and response types are built from smaller building blocks, such as types and parameter types. Types can be found under the types folder and are generated from the reusable schemas like our book and app error type here. Parameter types can be found under parameters. They are generated based on operations and parameter location. For example, getBooks query parameters collects all the query parameters for the getBooks operation, which is currently just a single offset parameter. Now, how is it all tied together? For this to work, we need an actual HTTP server library that needs to do the routing and exposing the HTTP functionality for us, like being able to read the request body and to respond. For this, I had to find one framework that oats would support by default, but new framework support might come in the future if there is interest. There were a few possible candidates. I experimented with vanilla Node HTTP server, Koa, Fastify, Next.js, and some others, but I ended up with the most commonly known and used one, which is Express. Our app is basically assembled in the createBookStoreRouter function, which you can find under routers. It takes an instance of the previously mentioned API type, takes an adapter, which is designed to mediate between the generated code and the framework, comes with an out-of-the-box implementation, but you can extend it or create a fully custom one if you wish. And routes, which can be used as a last resort in case you want to opt out from using oats for some operations. This function then returns an Express router, which is a composable primitive Express provides for routing. First, it adds a middleware that exposes both your API and adapter implementation on response.locals, which will be available for all routers. Then it adds all the generated routers, which we are going to have a look at next, or their overrides. So for each operation, a router is generated, and they can be found in the routers folder as well. Let's check out getBooks router. As you can see, just as the main router, this will be an Express router as well, but configured with the appropriate path and request method this time. First, it assigns three constants: toolkit, which is used to interact with the framework layer in the adapter. Then API and adapter are grabbed from response.locals. The following statements are wrapped in a safety try-catch, and the error is handled through the adapter, which by default delegates the error through the next function. Then the strictly typed request object is constructed by extracting the appropriate parameters using the adapter and the generated deserializers. Then the appropriate API method is called, and its strictly typed response is assigned. After this, the parts of the typed response get serialized, again through the adapter, and are converted to a response where everything is in a format that can be understood by any HTTP framework. Lastly, it responds through the adapter using this response that has everything serialized. The last thing I haven't talked about is how parameters, request and response bodies are serialized and deserialized. OpenAPI has a wide range of parameter serialization styles and configurations for query, header, and path parameters. Oats proudly supports all of them, regardless of how nonsensical some of these parameter serialization styles might seem. The generated serializers and deserializers can be found in the serializers folder. To avoid having huge amounts of complex generated code, they are powered by a supporting runtime library. As for request and response bodies, the amount of serialization methods is not finite, and I can't possibly keep track of every data format, as OpenAPI has no restriction on the MIME type of the request bodies and responses. So serializing and deserializing is done in the adapter based on MIME type, and by default only JSON and plain text is supported. You can add your bespoke body serializing and deserializing logic by extending the default adapter. That concludes this video. If you have any questions, comments, feedback, or anything you'd like to share, please do so in the comments or on the discussion page on GitHub. Links as always in the description. I hope to see you in the next video, where we are going to build a functioning server from what we generated with surprisingly little code.